Hi, let's do some acid-base questions. HCl and calcium hydroxide, hydrochloric acid, dissociation 100% strong acid, so you get H plus and Cl minus. 0.5 molar, 0.5 molar. So therefore, pH is minus log of the H plus, plug it in. You should get the pH 0.30, close to 0. Calcium hydroxide strong base dissociates 100%, calcium 2 plus, and 2 times of hydroxide, calcium 2 plus no value, and OH minus is this much, 2 times of the molarity, and then you look for the POH because it's hydroxides. Plug in, so you should be getting the POH value that comes to 0.15. Then pH is 14 minus 0.15, which is 13.85. That tells you it's a strong base. That's what we know, right? Okay, that's it. Let's move to the next question. So this is a guesstimate or estimate question, no math needed. So it could be a multiple choice question and you will not be given enough time to do math here. Can be done though, right? Sodium chloride, look at that one. Sodium is coming from sodium hydroxide, Cl coming from hydrochloric acid. Strong base, strong acid. Strong base is 14 pH, strong acid 0, midpoint 7, neutral. That's why sodium chloride is neutral in a solution, right? Now look at this salt, sodium bicarbonate. Sodium comes from, again, sodium hydroxide. Bicarb comes from carbonic acid. This is strong base, this is weak acid. 14 and 5, midpoint is 9, actually 9, and this should be basic. Let's fix this. Yeah, 9 and basic. Look at this one, ammonium nitrate. Ammonium comes Ammonium comes from ammonia. Nitrate comes from nitric. Ammonia is weak base, nitric is strong acid. So 5 and 10 and 0, which is 5 in the middle, it should be acidic. So that's how you do the guesstimates, and just practice few more salts, you should be good. No calculation needed for these guessings, right? Okay. Next question. So calculate the pH for this solution. Acetic is given, it could be given in any formula, CH3COOH, or acetic, HAC, and or C2H4O2 for this one, right? Now that's, I see it as HA, and then sodium hydroxide strong base given. Start with the HA, and you get the double arrow just for equilibrium, H plus and A minus. That's the easy way to look at it. And we are looking for pH, and pKa is given. Now H plus is the question, though. We are looking for it, right? So take the strong base, plug it in here. Sodium cancels out, OH minus, strong base. That's why forward arrow, single arrow. Do an rise table or ice table, right? Now let's plug in the moles of each. So it comes to, yes, 20 milliliter times 0.1 molar, and convert to liters, and then you plug in just a stoichiometry. So you get strong base comes to 0.002, and the weak acid comes to 0.02. Minus x, and x there, and 0.002 minus x, 0.02 minus x, and 0 plus x. So the data here, we know x is 0.002 based on the data in the question. This becomes 0, this becomes 0.018, and this becomes 0.02. So now we have the data, or the equilibrium values, plug in, and here you have to use the Henderson Hasselbalch. pH is pKa log base over acid. Remember, base over acid. So we plug in pKa, is it given? Yeah, 4.74 log, and base value is at equilibrium 0.02 divided by 0.018, and inside the bracket we should take their value, and yes, so we take the value of solve the inside and then log value and plus 4.74 will give you 3.78. So that's the pH of this buffer, and there are two components of the buffer, right? Now let's do the cocaine problem. So the cocaine problem, it's just a fancy structure given. That's actually the real street drugs when it's pure form, and it looks like this. And it's kind of a roof-like structure, and N-methyl and Q-methyl, hydrogen here and hydrogen down again. It's a, yes, and then you have a benzene structure here. One moment. Why it's not working here? Yeah, it should bench. Okay, good. Yes, OCO, benzene structure. So that's how it looks like cocaine. So again, equilibrium, and because it's a weak base, and even if we don't draw everything else, it doesn't really matter. Think it this way: BOH, weak base, goes into B plus, and hydroxide minus. Now, so this one I see is like ammonia, NH3. You see the nitrogen here, right? It's similar to that behavior. And it's a big molecule, and it's a neurotransmitter, all these, right? So for us, BOH, and molarity is given 0.04 molar, nothing at the beginning, minus XX, and 0.04 minus XX, and this goes to 0. Assumption X is a very small value. Because OH minus, write Kb, P over R, product over reactants, B plus OH minus and BOH divided by, plug in the X values, X squared over molarity, 0.04. Now, the Kb, is it given? Yes, Kb is given. Plug in the Kb, 2.6 10 to the minus 6, X squared over 0.04, cross multiplication, and take the root, right? So 0.04 times 2 times 10 to the minus 6, bracketed them when you plug into the calculator, and take the root to cancel the x squared. You get the x from taking the root of that. That x is actually hydroxides. That will lead you to POH. So the POH is minus log of the OH minus, and plug in the value you got, and that gives you POH is 3.49, pH is 14 minus 3.49, which is 10.50. Yes, and then that will give you a weak base. So cocaine is a weak base, right? Okay. Now, next one, this is number 4, this is number 5. Yes. So okay, so that's it for now. We go to the next question next time. Thank you.